you'll be seeing some questions of trigonometry, and basically they will take three questions from trigonometry, where the first question is like that: when tan c plus a by 2 equal to cot b by 2. Okay, it's given that tan c plus a whole divided by 2 is equal to cot b by 2. This is the question which is given to us, where which need to prove so basically it's given that when a b c are the interior angles of a triangle. Okay, are the interior angles of a triangle, right? Then in this case we need to prove that tan c plus a by 2 equal to cot b by 2. So students, in this case simply you remember a triangle. Okay, in any triangle, when there are three angles a, b and c, right, then the sum of all these angles will be equal to 180 degree, isn't it? So just remember in your mind, you will be using this a plus b plus c is equal to 180 degree, right? Just keep it in your mind, right? Now simply after this, just take the LHS of this identity which need to prove, right? This is a question from NCERT, so I've taken it, right? So here you can see, since a plus b plus c, since a plus b plus c is equal to 180 degree, okay, then we can say that here into the question, see this c plus a, mind this combination of c and a. So just we will also make a combination of c and a, this combination, right? Because this is also asked into the question, right? So here what we will do, we will keep c plus a into one side of the equation and just push b to the other side, and it will be 180 degree minus b, right? And here you can see this 2 is also there into the denominator of LHS, right? So do one thing, divide both side by 2 like this, right? When you divide both side by 2, then what will happen, you can see this c plus a by 2, c plus a by 2 will be equal to 90 degree minus b by 2, isn't it? Because 180 by 2 is 90, right? Now just take the LHS. when you take when you apply tangent to the LHS, this will be like this: tan of c plus a by 2. When you take the LHS, can't you write tan c plus a by 2? Can't it be written as tan of 90 minus b by 2? Because c plus a by 2 is 90 minus b by 2, right? So in place of c plus a by 2, we can write 90 minus b by 2, 90 minus b by 2, right? Now the LHS will remain as it is, and the RHS will be like this. Since tan of 90, we know that tan of 90 minus theta is what? Is equal to cot theta, right? You remember this identity. We will apply the same over here, okay? Then the above LHS will be equal to, that is tan of c plus a by 2 will be equal to tan of 90 minus b by 2. So in place of tan of 90 minus b by 2, so b by 2 is the theta over here. Mind it, b by 2 is theta over here, right? Just consider this. When b by 2 is theta, and into this formula you will put in place of theta as b by 2, you will get cot theta, that is cot b by 2, right? Because b by 2 is theta, so the LHS can be written as cot theta, that is b by 2. Here mind it, this b by 2, right? So it will be cot b by 2. In this way we have proved the first question of this session, right? Now coming to the second question, this is proved. Now coming to the second question, the second question which is asked to us is to prove, the second question which is asked to us is to prove sine of b plus c by 2 is equal to cos of a by 2. This need to prove. So just take the LHS. When you take the LHS, right, you can see sine b plus c. Similarly, in this combination a plus b plus c was 180 degree, right? So here you can see b plus c is coming, right? So just put up the combination of b plus c into one side and push a to the other side. Then what you will see, you will see that b plus c will be equal to 180 degree minus a, isn't it? Because a plus b plus c is 180 from the triangle. Now b plus c is 180 minus a, then just divide it by 2 into both these sides, then you will get b plus c by 2, that is b plus c by 2 is equal to 180 by 2 is 90 degree minus a by 2, isn't it? So here this is the relation which is derived. Now just what we need to prove, sine of b plus c by 2. So just take the LHS, this one, and apply sine into it, right? Then we can write sine of b plus c by 2, sine of b plus c by 2. I hope it's visible to you. Sine of b plus c by 2 can be written as, tell me, it can be written as sine of 90 minus a by 2, isn't it? Because b plus c by 2 is 90 minus a by 2, so it can be written as sine of 90 minus a by 2, right? Here a by 2, right? So here in this case a by 2 will be acting as a theta. If a by 2 is equal to theta, then we can use the formula. Which formula? Sine of 90 minus theta is equal to how much? Is equal to cos theta, right? Similarly, here if theta equal to a by 2, then can we write sine of 90 minus theta equal to cos theta? Then this RHS sine of 90 minus a by 2 can be written as this RHS sine of 90 minus a by 2 can be written as using the formula sine 90 minus theta equal to cos theta, then sine 90 minus a by 2 will be equal to cos a by 2, right? Isn't it? Then this cos a by 2 is same as cos a by 2 is the same as our required RHS. So in this way we have proved that sine of b plus c by 2 is equal to cos of a by 2, isn't it? We have proved it. So we have solved two questions of today's session. Now going to the last question of today's session. Okay, the last question which is given to us is, let me zoom a little. Yeah, it's better now. Fine, perfectly fine. Thanks for your patience. So here the question is that tan of 20 degree, then tan of 35 degree, then tan of 45 degree, then tan of 55 degree, and tan of 77 degree, 70 degree. So I'm writing all these angles. Tan of 20 degree, then 35, then 45. So it's very tan 45 is 1, we know that. Tan 45, then tan 55 multiplied by tan 70 degree, and all this is equal to 1, right? We need to prove it. We need to prove, right? So to prove it, what we will do, we will simply see the combination. Just leave this tan 45, leave it, leave this tan 45 as it is, because tan 45 is nothing but 1, right? So since tan 45 degree is 1, just leave it as it is, right? Then use the combination rest of the things. So when you put the value of tan 45 as 1, the above LHS, the above LHS will be looking like this. How? Tan of 20 degree, then degree, then tan of 70 degree, isn't it? Here you can see 20, 35, 55 and 70. Just think on it. Just think on it. Here you can see 20 and 70 can be added up to form 90. 20 plus 70 can be added to form 90. Similarly, here this 35 and 55 can be added to form 90. 35 and 55 can be added to form 90. Why I am saying this? Just because you think that if 20 plus 70 is 90, then this 20 can be written as 90 minus 70, isn't it? This 20, this 20 can be written as 90 minus 70, isn't it? Why into the form of 70 only? Because this tan 70 is already present over here, right? So what is the benefit? Let us see. This tan 20 degree can be written as, this tan 20 degree can be written as tan of, the LHS will be again looking like this. So this was into the, this is your, in the mind this is coming, okay? So that's why I'm writing it from a different color. This should come during the examination when the question will be coming to you. Then this 20 degree can be written as tan of nothing but 90 minus 70, 90 degree minus 70 degree. Is it fine? And along with this, make a pair of this tan 70 degree. You can. If you don't want, leave it. And again this tan 35, this 35 can be written as 90 minus 55, right? So tan of 35 degree, tan of 35 degree is written as 90 degree minus 55 degree. Why we have written like this? Similarly, because 55 plus 35 will be 90, and another term with 55 degree is already present into your question, this part, tan 55 degree, right? So here these, just change only two, don't change the remaining two, because when you change all, then we again will be sitting into the same situation. So just change only the two terms into the form of 90 minus theta. So we have changed tan 20 degree and changed tan 35 degree over here, and this is written as tan 90 minus 70 and tan 90 minus 55, and leave these two terms tan 55 and tan 70 as it is, right? So this multiplies by tan 55, which is already there, and tan 70, tan 70 degree. This is your LHS. Now our LHS can be further, our LHS can be further simplified as, this can be further simplified as tan 90 minus theta. Tan 90 minus theta is nothing but cot theta. Remember, tan 90 minus theta is cot theta. Tan 90 minus theta is cot theta. We will be using this formula over here, right? So here the first term tan 90 minus 70 will be changing, and we will be having tan 90 minus 70 is cot 70, just using the same identity, this one. So this LHS will be looking like this will be looking like this. How? Tan 90 minus 70 will be equal to cot 70 degree, right? Cot 70 degree. And this tan 90 minus 55 will be looking like, tan 90 minus 55 will be cot 55, isn't it? Cot 55. And the another two terms which are left is tan 55 and tan 70, tan 55 and tan 70, right? So just write it, that is tan 55, this is in product, so we can write anywhere tan 55 and tan 70 degree, right? You know that cot theta is 1 by tan theta, right? So here we can see this cot 70 degree is cancelled out by this tan 70 degree. Similarly, this cot 55 can be written as 1 by tan 55. So this cot 55 can be cancelled out. This can be cancelled out with this tan 55 degree, right? And the value of tan 45 is already 1. So we can write it as, this is product of all these will be equal to 1 into 1 into 1 into 1, and one another tan 45 is already 1. This is all multiplied, and we have 1 into the RHS, which is proved, right? So that means we have proved that tan of 20 degree, tan of 35 degree, tan of 45, tan of 55, and tan of, so I'm writing the angles again. So tan of 20 degree, then tan of 35 degree, then tan of 45 degree, then tan of 55. All the numbers, all the tangents are in product. Tan 55 degree into tan of 70 degree. We have proved all this product is equal to this RHS is equal to 1. And in this way, we have proved this identity, right? We have proved it. So with this, we are going to close today's session. Thank you so much for watching, students, and just keep on learning. Happy learning. Bye bye.